All right, Christina, hopefully this will help you out. Sorry if there's some ambient noise here. I'm outside and there's some motorcycles going by. But so you got to this point, and really all you have to do at this point is you have to multiply out the polynomial. So you can do this in any order you want, but I would typically start with that one right there first. And I'm going to multiply this whole thing out sort of on the side in green, the x plus 1 cubed. So in order to find x plus 1 cubed, what you need to do is first, I guess, sort of split it up. You're going to multiply x plus 1 times x plus 1 times x plus 1. And you're going to FOIL out, you can do this in any order as well. You're going to FOIL out two of them. Then once you get that answer, you're going to multiply out the third one. So I'm going to FOIL out this first two binomials here, and you're going to get x squared. The outer terms give you plus x, the inner terms give you plus x, and the last terms give you plus 1. These two terms in the middle you can combine because they're like terms, and you get x squared plus 2x plus 1 times x plus 1. Alright, now we can multiply this first, it's a trinomial actually, by this second term, it's a binomial. And that requires just distributing. So you distribute every term in the first polynomial with every term in the second polynomial. So you're actually going to get 6 terms here. And I might have to write pretty small, but the first terms are going to give you x cubed, and x squared times 1 is going to give you x squared. 2x times x is going to give you 2x squared. 2x times 1 is just 2x. And now you're going to distribute the 1 through the parentheses. 1 times x is x, and 1 times 1 is 1. Now, all of the like terms here, it looks like you have some x squared terms that are like terms that you can combine, and you have some x terms that are like terms that you can combine. You have a 3x squared plus 3x plus 1. Now, all of this that I've done so far is just this x plus 1 cubed term. Now what you have to do is sort of reinsert what we found here into our original problem and continue. So that's going to give you x. The x plus 1 cubed we found out was x cubed plus 3x squared plus 3x plus 1. And we still have that x minus 1 in there. Now, we still have to multiply out these 3 terms, and you can do this in any order. I am going to multiply the x through the first set of parentheses. And if you do that, you're going to get an x to the 4th plus 3x cubed plus 3x squared plus x. That would be these first 2 terms combined. Again, sorry about the noise. We still have this x minus 1 term as our second term that we have to multiply. Okay, so what do we have left? Well, we have a big distribution problem. We need to distribute every term in this first set of parentheses to every term in the second set of parentheses. So we need to distribute the x to the 4th to the x and to the negative 1, and distribute the 3x cubed to the x and the negative 1, and the 3x squared, and so on. And you can count up all the terms. We're going to get 8 terms here. 8 terms total. Then we can combine them, and we should be finished. X to the 4th times x gives you x to the 5th. X to the 4th times, keep in mind it's a negative 1, is going to give you negative x to the 4th. 3x cubed times x is going to give you a 3x to the 4th. 3x cubed times negative 1, negative 3x cubed. 3x squared times x is going to give you a positive 3x, cubed. 3x squared times negative 1 is going to give you a negative 3x squared. X times x is positive x squared. X times negative 1 is negative x. Now all we have to do is combine like terms, and we should get the answer. X to the fifth is its own term. It doesn't have any like terms. There are two x to the fourth terms that you can combine. You get 2x to the fourth when you combine them. Notice that you get a negative 3x cubed and a positive 3x cubed. Those terms just cancel. So we won't have any x cubed terms in our final answer. We have 2x squared terms though. We end up with a negative 2x squared. And we just have the one x term. Now hopefully, if I haven't made any mistakes here in any of the math on any of these steps, that should be the correct answer to the problem. I hope that helped.